Hey guys, welcome back to Algos Made Simple. I have one that's a little bit trickier today, but I think this one thought on this problem, this one thought will change the entire problem and make it a lot simpler. So let's dive in and get that one thought here. It's Leetcode 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. So I would let the interviewer know, I understand I'm getting a string, and within it, I want to return what the longest palindrome is. And so a palindrome, of course, is the same left to right. If you reversed it, it's going to read the same. So we look down here at the example. We got input S equals BAB AD. So you got BAB is your longest palindrome. On this one right here, you got CBBD. You got B and B as the longest palindrome right here, these two letters. So it can be odd, it can be even. What we need to do is figure out a way that we're able to diagnose if something is a palindrome, and if it is a palindrome, how long is this palindrome? So that's what we're trying to do here, and I'm going to go ahead and write that down, just try to simplify that. I know it's kind of self-explanatory, but we're trying to see, is it a palindrome? So something to figure out if it is a palindrome, and how long is the palindrome? So that's part of our game plan there. That's what's literally kind of being asked of us. So not rocket science there. So how can we do it? If we start at this letter and we check the B and we add an A to it, we don't know if the next letter comes in a B or not. If it is, we're having to keep track of this first character somehow or whatever. And it would take a lot here. It'd probably be like O of n cubed to go through this and kind of just keep track and comparison and all that stuff. The best thing that I've seen, and I didn't come up with this on my own, this was something that I just saw out there, and a couple people are doing it, and it's really just been a thought that's changed this problem for me. But if you treat every character like it's the middle of the palindrome, and then expand around it, and check the left and right pointers and see if they're the same, then that's the problem. That just makes this problem so much easier and so much just comes together when you start thinking about it like that. So treat every character like it's the middle. Okay? So what I mean by that is we go to this B, we treat it like it's the middle. We look at the left and look at the right. Nothing we can do there. There's not a palindrome we can build around there. The palindrome is just one. It's just the B. Okay, so we go to this A and treat it like it's the middle. To the left is a B, to the right is a B. The palindrome is 3 right there. And same thing over here, but the only difference is you have to have a difference for the even ones, where we're going to have our right pointer be one more than our left. So we go ahead and compare two letters to each other on the even ones and then expand out kind of thing. So let's take a look and see what I'm talking about here and see if coding it up makes a little bit more sense, because it is a very difficult problem to kind of wrap your head around. But I think that treating every character like the center is just such a big thought for this one. So let's look at it. We've got longest palindromic substring, and we're getting a string passed through, of course. And what we need originally is we're going to return our resolution. We're returning the longest palindromic substring. So we're going to return a string. So our resolution is an empty string for now. And we need to keep track of the length of this string so we have something to compare it to see if we've done better. Otherwise, how would we even know if we did better? So this length right now is 0. That's the length to beat. So from there, it's time to start pulling out our characters and treating them like the middle. So we'll say for I in range, length of S, so the length of the string, we're going to pull those I's out. And the reason we want to do I instead of just pulling the characters is we're going to set the left and the right there for now and then expand them from there. So what I mean is we're going to go left, right, and we're going to set them both equal to I for the odd ones. So if you have an odd one come down, this is going to happen for every character, but if it's odd, this is what's going to work right here. And we're going to say while left is greater than or equal to 0. So when we start to expand them, if it's expanded out here somewhere, we don't want to mess with it because it's not a letter anymore. It's going to be comparing null to null. And right is less than length of the string, So same thing, a boundary thing here. And S at index left equals S at index right. So these two letters, as we're expanding out, so imagine this A, and we expand our pointers are on the A here, both of them, the left and the right, and then we expand this left out, we expand this right out the next time through, and the letters are the same. That will keep this loop going. So if you look here at our code, we've got if right minus left plus 1 is greater than the res length. So for one letter that would happen, our initial one, it would go ahead and beat that 0. So we'd have our resolution, we'd set it to string left to right plus 1 because we want to have the right character included. And then we're going to go and update our res length, and it's going to be our right minus left plus 1, just like up here. And then all we have to do, guys, here comes the expansion. It's going to be left minus equals 1 and right plus equals 1. So we're still within the while loop. So again, if we started out here with our i's equal to this A, now the left's been bumped out here and the right's been bumped out here, and it's going to stay in this while loop. It's going to do this little calculation right here and see that we have a longer resolution length of 3 now, and then we're going to set it equal to that BAB, and then we're going to set our resolution length to 3. Okay, so what about if we run into an even number, or an even palindrome, whatever? Okay, so this, and we're going to have it run every time. We don't have to do conditionals to check if even or odd. We're just going to have it run for each one, and it won't work for the odd ones. It will work for the even ones, and same thing up top. We're going to do left and right, and we're going to set the left equal to I, and we're going to set the right equal to I plus 1. And again, the reason for that is, okay, if we have an even one, like this one right here, I want my left, when I get to this B, I want it to be the left, and I want the right to be this other B, and then expand out from there, as opposed to if I treated this like it was the middle, which I would do in this odd portion, it's not going to work because the left's going to be C and the right's going to be B, but it is still a palindrome. There's two B's together, and I would never get it with this odd code right here. So for the even one, all I change is this, and then I'm still expanding out same way. So I'm going to take this, and I'm just going to put it right here and do the exact same thing. And then after all of that, once I get through this for loop, so let me make sure I'm in line there, I'm just going to return the resolution. So not too bad, guys, when you have this one core thought of, hey, I'm going to treat every character like it's the center. And to do that, I have to make sure these even palindromes or even strings aren't left out, because if I treat every character like it's the center on an odd one and just start expanding out and comparing the C and B, it's not going to work. But if I compare the B to the B, that's great. But on these odd ones, hey, I'm treating this A like it's the center, and I want to check out the left and right of it. And so I think that's a big time thought and something that's really helped me out on this problem. I'm still going to go through and do this problem a couple times just to really make sure that I feel like I've got this in my head. But for a more difficult one, you could do a lot worse. So I really appreciate you guys taking the time to check this one out. And I believe it's O of n squared, which for this problem is not too bad at all. Again, thanks for watching, guys, and hopefully I simplified it for you a little bit, and we'll just keep attacking these and keep trying to make them as simple as possible. Thanks again.